we are ready to start the third method to find the delta H of a reaction, and that will be the last video of this course. So we're trying to find the delta H of a reaction from the standard enthalpy of formation. What is the standard enthalpy of formation? Well, that's the heat exchange that results when 1 mole of a compound is formed from its elements in their most stable form at a pressure of 1 atmosphere, and that is defined as standard state. So if it's a gas, it's in 1 atmosphere. If it's a solution, that's in 1 molar solution. Then that's defined as standard state. And if you see that little circle on top of that, that shows standard state. So that's standard enthalpy of formation, and we have F here as enthalpy of formation. So for standard state, if it's a gas, it needs to be at 1 atmosphere. If it's a solution, it needs to be in 1 molar. And that defines the standard state. So the temperature doesn't need to be there, but in most tables you will see that it is written as these values are at 25 degrees Celsius. But because gases, if you change the temperature, you might have a different pressure. So they just mention it there, but that's not part of the standard state. So these values are the values that scientists went ahead and did all of those things using calorimeter, using Hess's law and everything, and found these numbers, and they put it all in table. You can find these values in table 6.4 in your book, or a longer list in appendix 8.2. You can find all of the standard enthalpy of formation for all elements in these sources. So we are not ready to use standard enthalpy of formation to find enthalpy of a reaction yet. So first we have to talk more that what does that mean? What is delta H of formation? So for example, you go back and look at a chart and find the delta H of formation, standard delta H of formation for magnesium carbonate, MgCO3. So you find that value and you will see that that has this value. Okay, what does that mean? So by definition, we said that standard enthalpy of formation is the amount of heat or amount of energy required to make 1 mole of the compound from its component in standard state. Okay, so this compound, this is our compound that you want to find the standard the enthalpy of formation, standard enthalpy of formation. So the energy required for 1 mole. Okay, so if you have, this is the equation, right? This should be 1, because by definition the amount of energy for 1 mole is the standard enthalpy of formation. So that's the first part of the definition, energy required for 1 mole of the compound. And the second part, it says from the elements in their standard state. Okay, so in magnesium carbonate, we have magnesium, we have carbon, and we have oxygen. Okay, so what is the standard state for these three? For magnesium, the standard state is elemental metal, right? So the standard state for magnesium is Mg in solid phase. The standard state for carbon is in graphite mode, graphite phase. Okay, so carbon as graphite, which is solid, and oxygen, the standard state for oxygen is diatomic molecule. Okay, so it's O2. Okay, so these three components should be in their standard state, otherwise it is not delta H of formation. Okay, and then you balance the equation in a way that you have 1 mole of the product. So if you remember, when we were balancing the equation, we didn't leave the equation when you have a ratio like this. But for the delta H of formation, because from the definition it's for 1 mole of the compound, we balance it in a way that we have only one of that compound. Okay, so that is the chemical equation for formation, delta H of formation of magnesium carbonate. We're not going to use the delta H of formation to find the delta H of reaction yet. So let's answer this question to make sure that we understand what is delta H of formation, and then we move on and see how we can use the delta H of formation to find the delta H of reaction. Okay, so if we see the delta H of formation of methane CH4 to be negative 74.6 kilojoule per mole. Okay, so which of these reactions is the right one for the delta H of formation? So by definition, we said that the delta H of formation is the amount of energy to make 1 mole of the product of the compound. Okay, so that compound should be in the product side, right? So if CH4 is in the reactant, so that cannot be the answer, right? And it's 1 mole of that compound, not 2 moles. So in D, we have 2 moles, so that cannot be the answer. So we can cross out A and D. And that also cross out E as well, because 3 and 4, so it's not E, so it's either B or C, right? So it's 1 mole of product, so both of them are 1 mole. And the other part of the definition says from the elements in their most standard form. So carbon, the standard form is graphite, which is solid, so I just write S here, but it's okay, graphite is solid, so this is in the standard state. Hydrogen, the standard state for hydrogen is the diatomic molecule is H2, it's not H, it's not atomic H. So this is the standard state, and C is the answer. So we can cross out B, and the answer is C. So if you have this equation and you find the delta H for that delta H equal the delta H of formation, the standard delta H of formation. So for this one, before we pause and think about the answer, just think about a definition of standard enthalpy of formation. It's the energy required to make 1 mole of the compound from its elements in the standard state. So think about that. What is the value for delta H of formation, standard delta H of formation of O2? Well, if you want to make O2 in the standard state from O2 from the elements in their standard state, what is the standard state for oxygen? It's O2, right? So do you see a change here? No, so there's no change. Therefore, the delta H for this reaction, which is delta H of formation, equals 0 kilojoule per mole, right? So the answer is 3. It must be 0. Okay, so now that we know what is the standard enthalpy of formation, let's see how we can use that to find the delta H of reaction. Okay, so the enthalpy of a reaction is carried out at 1 atmosphere, right? So the delta H of formations are used if the reaction is at 1 atmosphere standard condition. The delta H of formations are used to determine the delta H of the reaction according to the following equation. So the delta H of reaction is, you see this sign here, that's sigma, that's a summation. So the summation of delta H of formation for all the products, the final stuff, minus the sum, sigma, the sum of delta H of formation for all the reactant stuff, all the initial stuff. Okay, so it's final minus initial, products minus reactant. So the delta H of reaction is the sum of delta H of formation of all products minus the sum of delta H of formation of all the reactants. The N and M are the coefficient of in a balanced chemical equation. Okay, so let's do this on a practice problem so you get it better. Okay, so we have this equation here, and as I said, delta H of formation, you can find the values in references in your book, and there is a long list of everything with the delta H of formation of everything. So you can get that and apply it to your question. So we have this equation. We want to find a delta H of the reaction using the delta H of formation of each of these. Okay, so the delta H of formation reaction is the sum of delta H of formation of products. Okay, so in product I have CO2 and I have 4 moles. Okay, so that's N and M. We talked about in the previous slides. These are the coefficients. So 4 times the standard delta H of formation of carbon, not carbon, the CO2. So delta H of formation, standard delta H of formation of CO2 plus, you have to sum the product, 2 moles of delta H, standard delta H of formation of water in liquid phase. And that's important. This is gas phase. Okay. So I pulled out these numbers and put it here from a big table, but when you're doing your homework, there might be a link that you click on it and it shows you everything. So you have to be careful. When you go to the main table, you might see H2O in liquid, H2O solid, H2O gas. So you have to be careful which of these values you're getting. Okay. So it's H2O liquid, and that's all my product minus all my reactant. So I have C2H2 in my reactant, and I have 2 mole of that. So 2 times the delta HF of the C2H2. So delta H of formation of C2H2 in gas phase plus 5 moles times delta H, standard delta H of formation of O2 in gas phase. Okay, so you plug in these numbers and then you find the reaction and tell me what is the answer. So if you check the table, you have all the delta H of formation except oxygen. And why is that? That's because the same reason we talked in the previous slides, that for oxygen the delta H of formation is 0, and that's true for all the elements. So if you have anything in the standard state, the delta H of formation is 0. So if in your reaction you have H2, you have O2, you have N2, like you have metals in their elemental form, solid, these are all the standard states, so the delta H of formation is 0. So if you put 0 here, you should get a negative 2598.8 kilojoule for this reaction. So it's negative 2598.8 kilojoule for the delta H of the reaction. So basically the third method is just taking the numbers from a table, find this delta H of formation of each compound, the reaction. The reaction should be balanced, the equation should be balanced. Use the coefficient, multiply it by the delta H of formation of each compound, and use this equation to find it. The common mistake in these kind of question is you have this negative here, you subtract the first term, but you add the second term, and that's actually when, if you do that, you probably get this one. Okay, so in the exam I might add all of these options that if you make a mistake you get these number. I put it in the options, and you have to be careful. You have to get the sum of the whole thing first. If it helps, write it down on your scratch paper and get the sum of that. Write down a scratch paper, and then you subtract those two. Okay, or in your calculator you can put the parentheses and that fix that. So whichever you feel more comfortable, but make sure you get the right answer.